So during the breakout session, I assume you've converged on some sort of a summary of what are the interesting aspects of using FRBs as probes for astrophysics, cosmology, and stellar astrophysics. So let's have a discussion. Does anyone want to summarize? Yeah, let's talk about the stellar astrophysics. Yeah, if someone could summarize from each group.
Yeah, it's in the stellar group. We had a couple different conversations. One of them was that this sort of growing consensus that there's a lot you can do with bursts that are within about 100 megaparsecs, but there's only so much volume in the universe out that far. And so you would ideally be able to localize bursts, but have an all sky monitor at the same time. So we talked a little bit about that. Then we focused on a couple of interesting questions. Let's see, I had just a couple notes. Some of it was thinking about whether all of this sort of question of delay time distributions of progenitors would be impacted if your progenitor model is actually emitting bursts for quite a long period of time, but decided that maybe that doesn't matter if most of the current source models would only be bursting for, thousands of years or so, as opposed to gigayears. Similarly, we know that FRBs probably aren't only coming from superluminous supernova. We know that from their host galaxies already being quite different, but what you would need to say the opposite, that superluminous supernova don't make FRBs, and whether or not there's already evidence of some overabundance in dwarf galaxies, which might indicate a subpopulation. And then finally, building on that, thinking about if you do want to start subdividing into populations, what are ways that you could do that for FRBs? In gamma ray bursts, you had duration, and supernova, you have spectra, but how are we going to subdivide populations besides just repeating and not, and whether or not we're getting the types of data you would want from current experiments to be able to sort of come up with subpopulations of FRBs.
Great, thank you. Any comments on that summary?
Just one very quick comment is, I think burst properties are a very useful thing, but the potential pitfall is, I guess it's just reflecting microphysics as opposed to something that is more indicative of really a different source type. Yeah.
We also had a group online, right? Okay. Any other comments? Okay, so let's go to the remote participants. Could someone please summarize the cosmological aspects of using FRBs as probes?
I could do that, I guess. So a couple of things again that we discussed. So one thing is that FRB's dispersion measures can be incredibly powerful in probing various things, H0, for instance. But at the same time, and especially with foreground mapping, we can also do pretty cool things, like doing the Flim Flam survey, trying to constrain the fraction of baryons in the ionized phase in the diffuse intergalactic medium. That being said, we felt that FRBs can either probe cosmology or it can probe gas physics pretty much. It cannot do both at the same time. Because we saw the degeneracy between F and H0, for instance, in Clancy's talk this morning. And given that there are very precise cosmological experiments, it might be better for us to try to constrain physics, or at least feedback mechanisms with FRBs. As for other aspects of FRBs, things like RM, for instance, we will probably need quite a few FRBs that before we start making very robust constraints on the large-scale magnetic fields in the universe. One thing we were excited about, however, is the fact that DESI is going to come online, and there's going to be a lot of timeout trigger FRBs. And the power of combining these localized bursts with the foreground data from DESI would be quite remarkable, and something that we would be excited to look into in the future, both in terms of foreground mapping and in terms of host identification.
Great, thank you. I guess it's a good time to summarize the findings of the cosmology group in person. Adam?
Okay, so the discussion started with talking about, well, the prospect of detecting those super high DM FRBs, whether they exist or not. So we talked a bit about, well, first talked about what looks like it's immediately possible, and that the options of mapping the CGM and breaking the degeneracy and the KSE effect look like the most promising avenues for immediate future. But it very quickly turned into a conversation about scattering from the CGM and from intervening halos, and how that might affect the odds of detecting high DM FRBs. And so, yeah, the high uncertainty in host DMs came up as a barrier to precision cosmology, but well, you mentioned that cross correlation can pin down the host DM distribution and sort of help in that effort. Yeah, and there was oh yeah, it was a question of whether or not the scattering timescale is correlated with DM, and from Pragyachala's paper, it seems it wasn't, but there's a likelihood that with angularly broadened sources from very high DM, you'll see less scintillation from the Milky Way, and that would be a way to distinguish the two, or distinguish high DM scattered events from low DM. And that's about all I can glean from my really, really bad handwriting here, so I'll get it back to you.
Thank you. Any comments on those points from other groups? Okay, so FRBs as probes of astrophysics. So we have someone to summarize?
We were doing galaxies, is that what you mean?
Probes of astrophysics, not stellar astrophysics, just, yeah, galaxies.
Okay. So I'll talk about like the very nearby stuff. I didn't take notes, so it's just kind of off the top of my head. So we talked about the bounty of the M81 repeater, how great it was to tell us about the DM contribution of the Milky Way and the Milky Way halo. We talked about how we can ensure that if another FRB goes off really nearby, potentially in our local group, we can ensure that we detect it in the regime before GREX. We talked a little bit, we wondered if anyone at Cornell potentially had been working on an updated galactic DM and scattering map. Additionally, we wondered if we even need a 3D map, and what the future looks like for such DM and other maps, and if it'll always be an upper limit using fast radio bursts. So one thing that we kind of talked about is with increased localization, and hence more idea of where the hosts, what are the hosts and where FRBs come from in their host galaxies, we'll be able to start to make a probabilistic statement, the way we're able to probabilistic statement of DM versus Z for the McCart relation, to also disentangle this contamination, in my opinion, of DM host when we're looking at the galactic contribution. And then, of course, the more we know about our own galaxy, the more we can learn about how it was formed. And then I'll let Mubdi talk a little bit more about distant stuff.
Yeah, so part of the discussion also then led to asking how well can we do about learning about other galaxies based on how little we know about the probes within our own galaxy. So for instance, how well do we need to nail down local DM contributions before we can say anything about intervening DM contributions? And are there other ways of being able to probe that? And so that came up with a couple of different ideas. One of the big questions, we do know that there are intervening things within our own galactic halo. High velocity clouds was brought up in terms of a potential DM contributor. Is that a signal that we can see from the population of FRBs that we have now? There was a crazy idea about whether or not we can see absorption lines using FRBs as a backlight. If we get a larger and larger population and FRB signals travel through other galactic halos, can we start to use that as another probe in the same way as quasars, for instance? And so radio recombination lines will probably be hard, but potentially H1 would be a natural thing to be able to do. And that tells us, because if we have an intervener and we can, understand what the intervening redshift is, we'd be able to very well nail down properties of that intervener based on the FRB backlight.
Especially if you have a repeater.
Exactly, yeah.
Great, thank you. Any comments?
Yeah, just a quick one on the absorption line. So that was a nice proposal from a few years back. Oh, I had an undergraduate student, or rather Kelvin had an undergraduate student who tried this, and the scintillation turned out to be way too bad of a background. So like the FRB spectra just aren't smooth enough because of scintillation, and you can't even look for absorption lines. It's just a mess. Even if you had the signal to noise to go after them, which is another serious issue, since we typically have signal noise 100 over the whole bandwidth, right? Here, we were looking for 21 centimeter absorption, yeah. Well, I mean, we didn't think about it that carefully. We just searched, and then very promptly gave up searching when we realized that the scintillation was such a mess. Yeah, it was chime data. Yeah, very high signal noise baseband data.
I did very briefly try to stack repeater spectra. I was looking for very high DM repeaters with multiple events and stack the baseband data on those with the hopes that that's smoothing out the scintillation, and didn't have a lot of good material to work with, but mostly because it needs to be high DM for the 21 centimeter line to be in our band. And there would also come across against the cutoff from the spectrum from the baseband buffer.
Yeah, we've looked at that with ASCAP data as well, and of course it's hopeless. But we have redshifts at least, and it was more like looking for H1 from the host galaxies. So that's the thing to be, looking out for with L-band low redshift FRBs.
I was only going to add that we'll have redshifts for chime FRBs soon, and then maybe you could choose some redshift range and just stack those. And
Sorry.
Any other comments? No? Okay, great. I guess we're done. Yeah.
Hello? I don't know. Yeah, so we're entering into the last session. And we wanted to start the session off with a moment of silence for everyone to reflect on what we've learned from this meeting. Maybe like get out your phone or your laptop and write down 1 or 2 points that's like your main takeaways. And after that, we'll follow that up with a meeting summary by Jason and Keith. And then the rest of the session is just an open floor discussion to share your thoughts on what the most important things that you've learned when we're entering into this era of large number of localized FRBs.
Yeah, so I invite everyone to spend a minute to think about what's most important to you, what you've learned. Okay, was that enough time or would people like more? I'm getting thumbs up. Okay. Okay, great. So now I'd like to invite Keith and Jason to present the meeting summary.
Okay, yeah.
I'll use this one.
We're ill prepared, I guess.
A little bit.
Yeah.
I did notice though on the agenda, there's not really a spot for this later. So just before we go into this, I wanted to say thank you to the LOC and SOC for organizing a fantastic meeting with really a great program and, you know, all the critical people here and a beautiful venue, which is still surprisingly hard to get into. Well done.
Yeah, so this is kind of a tag team talk, so I guess we're just going to say stuff
Slide
in
by
random
slide.
orders. And the vibe is kind of casual, I guess. So feel free to interrupt us and throw rotten tomatoes if you disagree with anything we say. So first off, we kind of did this in order of the sessions of the meeting. So on the first day, we talked about what localizations can teach us. And we had a bit of a discussion about, you know, is it better to have a bunch of sources or a few oddballs? Oddballs can clearly lead to some pretty big surprises, but then you can also ask the question, you know, are they actually representative of FRBs in general? And one of the things that surprised me on the first day of the meeting was you got the impression that people are really thinking that there are multiple types of FRBs at this point, and this seems to seesaw back and forth all the time. And at the FRB meeting in Cornell last fall, I felt like I was getting booed off the stage for suggesting that all FRBs are not magnetars, regardless of where they're found or what they do. They're all magnetars, but I'm getting a different vibe at this meeting. I don't know, put up your hand if you think all FRBs are magnetars. All right, well, you're in the in the minority now. Okay, so if they are coming, sorry. Yeah, go ahead. No, this is supposed to be casual. Yeah. Neutron stars.
Yeah. Neutron stars.
Neutron stars. Okay. Why not creating black holes?
No answer.
Yeah, there are creating black holes in spectrums. Yeah. Okay.
So I think they might be multiple things, but they're probably not too many multiple things that we're detecting now, because then you'd have a fine-tuning problem with them all having about the same rate, right? So there's probably one dominant channel. It might not be magnetars. Hope it's not magnetars. Don't just want to always be studying magnetars.
Brian disagrees
Your
vehemently.
PhD supervisor is sitting just over there. Yeah.
Well, I'm not sure the fine tuning argument works in practice because there's 5 different types of GRBs. Well, that is true, but still there are at least 2 that are, there are still 2 that are dominate.
Yeah, I guess my comment is that, you know, probably the majority of them are 1 or 2 classes, and then we have a few, you know, maybe there's some oddballs, maybe SGR 1935 and what's in M81 are oddballs, and they don't match what the rest are. But, you know, I don't think we have 1,000 classes in FRB.
I know, whenever the nearest things are the oddballs, you've always got to worry about what you're missing.
Yeah, we'll come back to that at the end of the talk. We saw some nice examples of FRBs as probes. So I'm not a cosmologist. When I talk to cosmologists who work on FRBs, they're really excited about FRBs for cosmology. When I talk to other cosmologists, I don't hear them talking about FRBs so much.
Yeah, that's probably fair. I think it's still early days, right? We haven't got these large, well-localized catalogs that we understand well, that we can do precision cosmology with. And it'll be a while before we can, I think, based on things that have been presented. You know, John gave a beautiful summary, which we'll get to later, I guess.
Yeah, John's summary was beautiful. But as an outsider in cosmology, I would say, like, do some marketing would be my advice. Yeah.
We don't have full penetration yet. That's true.
Okay. I'm a believer. Don't worry. Yeah. Okay.
Jason, that's partly because we kind of stretch the definition of cosmology to suit our purposes, right? Like the CGM stuff, beyond the applications to like weak lensing systematics, it's not really cosmology, right? It's galaxy evolution.
Yeah,
And
there's
so,
confusion already about what was astrophysics. And
yeah,
cosmology.
and that's fair. I think we should accept that it might be unlikely that we'll measure the cosmological parameters to better than a percent. And so that kind of cosmology, maybe not,
but it does give unique handles on a lot of things. In the interest of time, on to session 2, when we went through some of the FRB localizers. There's a discussion period after this, so we can come back to any of these topics that people want. I think Ziggy will organize that. My impression through the conference is that we've actually got an impressive diversity of projects still ongoing. Prior to this, I was thinking we were starting to collapse into a few small a few large collaborations, but my impression now is actually that there are quite a few ongoing, from EVN and with Precise running and Craft on ASCAP. DSA 110 is starting to come online, Meritrap, Aperitif, VLA, all the other things that can localize FRBs. There are a lot of things ongoing. In the next year, we start to get really distinctly purpose-built FRB localizers. We're not repurposing the VLA or the EVN anymore. We're starting to, have Chime FRB outriggers built just for this, and Graco built just for getting large numbers. In the near term, more of those things start to come online. Cord will be online 2025. I put Burst on there. I don't actually know the timescale. It's probably longer than that, but we'll get back to that one later. And then the midterm things like DSA 2000, SKA, all the big arrays will be coming online.
Yeah, and I just put down, it's going to be interesting to see if they all agree on what the population actually looks like.
Yeah, these definitely are going to see different slices of the population, which is nice to see. Things like, Burst, which it will be all sky and shallow, versus Cord, which is a small fraction and deep. Yeah, I think we're going to have interesting selection functions here that should hopefully probe the range.
It was interesting, though, that Clancy mentioned that ASCAP and Chime were getting the same luminosity distribution and maximum energy. Probably just a coincidence, though. Yeah.
Existing and upcoming follow-up infrastructure. It seems like there are a couple teams here that have really gathered the world's resources. I was particularly impressed with the deeper, wider, faster. Just the diversity of facilities that are brought to bear on a lot of these things is really impressive. And then F4, obviously. And clearly, there are a lot of resources that people are able to secure for following these things up. There's interest in the community that we're able to get, X-ray satellite time through VLA time. And DESI will come online. We'll start releasing data soon so that we can get large quantities of stuff on these sort of things.
And I put this plot. Is X still here, or did he leave already? Yeah. So is this actually in a paper, this plot?
Versions that are close. Oh, sorry.
There are
not
versions.
that specific one. I think in the
Yeah.
path paper we have something like that. And
I thought this was an insightful plot for me, at least, because I was interested to hear about the,
Hmm.
slowly increasing number of sources that have no host.
And in Manning's et al., there's a version of this that was actually inspired by your question in New York as to whether we were misidentifying the hosts because there were our R1 hosts underneath.
Oh, I see. Yeah. Okay. Okay. I like your shirt, by the way.
Yeah, I copied your style.
All right. Do you want to take, or should I start with this one?
Sure. You can.
Yeah, one of the things I'll remember from this meeting is Maria's point about being a careful curator. I think that's going to be really important. I was pretty shocked actually to hear that. So Swift has 149 short gamma ray bursts now, right? And only 56% of those are really robustly localized to a host galaxy. Is that correct? Yeah. Yeah. That's kind of concerning, right?
The ones that we're missing are like along high extinction sight lines and really poor localizations. And so there's no hope for those cases. So for the ones that we can localize their galaxies really well, we're only missing about 6 host galaxies out of 90.
Okay, so you think the pitfalls will not be as extreme for FRBs?
I hope not.
Okay, yeah, that sounds positive. We had the important point that, we could be more efficient in terms of follow-up, be less competitive with that and try to coordinate more. My question about that is how, actually? I don't know. maybe we need some kind of like FRB hub or something where people come together and
I mean, this sort of meeting, right, is.
this
the
is one way
closest
of
thing.
doing it. Yeah.
Yeah.
Yeah. All right. And I really like the point of making observing windows public as well, so we can do more.
Yeah,
ad hoc
I actually want to
observing.
double down on that last
Yeah.
one. That's something that I heard several times, that in addition to announcing events after they happen, if you can announce when you're going to be looking at where before it happens, that's helpful for other people to do, commensurate observations across a wide range of bands. And even if it's only a small fraction of the time that anyone bothers shadowing you, that's when we're going to have shadows. It's going to be much more efficient.
Yeah.
So I strongly encourage, there was some question of whether VO events could contain that information. But if not, then we should try to establish a format that is community-wide that can contain that.
I checked again yesterday in the white paper. There is a paragraph that explains how you can use a VO event to coordinate follow-up or observing. It's not obvious, but it does give a start.
So for Chime, which is just always observing, how would we do that?
Well, ours is, I think, effectively public anyway. We just need to tell people the coordinates, latitude, longitude, and you know where we're looking.
Yeah.
And it is a relatively inexpensive thing for basically all these surveys. There's a point and stare mode, right? So it's not costing people a lot of time once they know when they're looking to post that somewhere. Again, I don't know the proper venue or mechanism, VO events maybe.
I have seen people try to put together web pages that actually show you can just put in a source coordinate and you can see what telescopes are looking in that direction at any given time.
Yeah, so if we had, a week of lead time on that, a month would be great.
Yeah. This morning we had some really nice talks again. Clancy, Alexa. I was shocked to see that what I thought, was maybe the original paper was not the original paper. Oh, this is kind of blocked by an icon down here. But this paper that Clancy mentioned, which I was not aware of, has only 17 citations in the last 15 years. It's not very good. But yeah, not his fault. But it really emphasizes this joke, of course, that everything that you think of, some Russian theorists thought of it in the 1960s or 1970s already. Clancy made the important point that the McCart relationship is very noisy. It sounded like Jonathan was more sanguine about it. But, yeah, and then in terms of identifying subpopulations, as we were discussing, I'm not so convinced that just global galaxy properties are going to be that great for identifying the progenitor or subpopulations. It seems like a pretty noisy way of doing it.
Yeah, the discussions that I sort of sat in the background and was a fly on the wall for, it sounds like identifying the subpopulations is going to be difficult and require pretty broad follow-up and just a lot of crossing the data every which way, trying to figure out how it separates, looking for common modes.
Yeah.
For people who haven't looked it up, the paper is actually, that's all of it. It's only half a page long.
Yeah,
It's
that's
a fun
literally the
read.
whole paper. Yeah. It's called Possibility of Determining Intergalactic Gas Density by Radio Observations of Flares of Remote Sources.
It's exactly describing FRBs.
Yeah. Well, I mean, like if you dig into this as well, like Sturl Finney has a paper with Joe Taylor searching for FRBs in 1979 as like a high school student. Yeah. Like, yeah. So, I mean, that's kind of depressing, right? Like, what was I doing in high school?
I have a question regarding the third point. I was wondering if someone knows of any study or has tried themselves to sort of reconstruct the different subpopulations of GRBs just based on these sort of observables.
Well, there are papers from like 15 years ago or so showing that short GRBs are really offset more, right?
Yeah, and I think that's a case too. Like the GRB one, I mean, it's a good analogy, but it is also one where the two populations have about the most extreme different type of progenitors you can imagine, like a merging neutron star that takes gigayears to merge and is offset and kicked, and probably the explosion of the most massive star. So you can, like, the host galaxies are very different for those two, but as soon as you're not in that scenario, it becomes harder.
I'm not aware. Was there like a clear smoking gun that that distinguished the two at some point, or it was more like evidence? Evidence.
At least with GRBs, the first short GRB to be detected by SWIFT was found in a very old quiescent galaxy. And so that immediately pointed to the fact that it must have an older stellar progenitor. And so then I think the next one was even a quiescent galaxy. And then we started detecting more star forming galaxies after that. But the population of finding short GRBs in these really old galaxies definitely distinguished them from long GRBs. And then with the offsets and all the other information that came along with it, the redshift distributions, I think we were able to more securely separate those populations.
Yeah, and I'd say coupled to that, then some of the early, like in 1998, when we detected a supernova associated with a long GRB, then that set the other side of it, right? So, yeah.
Sorry, just to add on to that last point, I'm not sure I'm so pessimistic about subpopulations kind of being identified. So we talked about this a little bit in our last breakout group, but you know, if for instance, some subset of FRBs live in dwarf galaxies, then that subpopulation will be pretty clearly offset from, you know, the rest that might trace typical star forming galaxies.
And I guess there's a bit of a hint given that the two PRSs are in dwarfs. Yeah.
This morning, we heard about these three sort of really what will be, I think, transformational surveys that are going to be incredibly useful for well, gain redshifts on every FRB and well spectra on heaps. I've heard a few comments that Ruben may be not perfect because it involves, well, we're not going to be able to catch transients with it because there's some chance that there are no long optical duration transients. You know, if you're not on it already, you missed it. But in any case, the survey alone will be valuable. And then DESI is going to be coming out with their data release soon, which will be tremendously helpful for associations. And SphereX gives you basically all the redshift information on all of the FRBs when that data starts dumping out, which seems, certainly that was news to me and is incredibly promising.
Too late in the organization for the meeting, I also became aware of Euclid, which is a European mission. Does anyone know about that mission and in this context, how useful it will be?
Very, I think, yeah, very.
But is it basically doing a similar thing as SphereX?
It's less sky. It's way less sky. Yeah. There's a few very deep fields.
It's 15,000 square degrees, I think, and it's going to be diffraction limited, 100 millarc seconds, something like that. Incredible images. It's primarily a weak lensing survey, right? Yeah. So maybe a quick action item that, what's that?
It's only photos.
Oh, yeah, it's true. Well,
So Euclid is only photoz's.
Yeah.
Is what? And there's also
GRISM. There's a GRISM experiment as well.
a GRISM.
Yeah.
I'm sorry. I was just gonna say, but it's photos is infrared and a little bit into the optical. But if you wanted something that's like, say, 0 to redshift 0.5, you really need like U-band. It doesn't have that. So photos are gonna be a little bit tough, but it's still gonna be really good. Yeah.
Okay, can you go back to the last slide? Maybe a call to action or an action item for this workshop would be anticipate maybe 2029 or something. We'll have 5 to 25,000 localized FRBs from Cord and DSA 2000 and Krakow. We'll have all of these plus Euclid, right? Let's run a mock FRB survey and ask how many host galaxies will we have? How many interveners will be mapped out? Or do we have all the relevant information? Because, you know, obviously we can't be writing 25 JWST proposals per year and these sorts of things don't scale. So, and I'm happy to work on that if you want to work on that with me.
All right. Today in the afternoon, we heard about well, 2 great talks about what we can do in terms of constraining astrophysics and cosmology, and where the boundary is, I guess, is nebulous at this point. Yeah, one thing I wanted to flag though is I'm really excited about like lensing applications, but I'm a little bit dubious about how well this is going to work in practice. Yeah, I don't know if anyone wants to comment on that, but I mean, people often talk about just cross-correlating the voltages, but lens copy is traveling through a different,
Well, I mean, okay, so I mean, there's so many regimes. That is in itself a zoo. Like the one that Calvin has studied is, the microlensing regime where the paths aren't that different. You can still lose coherence because your lens can resolve the source local scattering screen, and that decoheres the whole thing, and that really has, weakens your constraining power a lot. And but that's a big astrophysical uncertainty, is how where is the scattering happening in FRBs. We know it's everywhere, and there's more than the host galaxy can provide. And if it's really close in, then actually you don't decohere too badly. But then I think Daniele had the other. Well, I mean, there's many things in between, but the other end of the spectrum is you're looking for strong lensing by whole galaxies, and then you're really trying to discover them in the imaging by localizing them to known optical strong lenses, right? And then doing things like trying to anticipate when the second image arrives and stuff. So it's a very very different regime, and those have lots of cosmological applications. So I mean, I think, yeah, it's a zoo, and there's astrophysical uncertainties, and we'll see how it kind of plays out.
okay. We're almost done. Are you giving us a time warning, or you want to say something?
Like a strongly lensed FRBs could also show up in statistical cross correlations, and that's something that we haven't explored yet. Like we need to pin it down. That would be really interesting.
Yeah. All right.
All right. What are we going to have? I've heard a lot of discussions here. I tried to put up sort of a timeline of when things are coming online. Yesterday, a couple of talks referenced, what do we do in the era of 100 localized FRBs? And I think, looking at this, we've got to realize, Krakow, how's that pronounced? Krakow, okay, is coming online, end of the year. And a year from that, they'll certainly have, 100, if those timescales are right. There are several things online today that are producing sort of now currently 10, 15 localizations a year. A year from now, we're going to be up to 100 a year. A year from that, up to 1,000 a year when the outriggers for Chime FRB come online. A year after that, Chord comes online, and 10,000 per year. And maybe there's some slop in this, but you can see there's a very steep exponential rise here. We're going up an order of magnitude a year. So we should be thinking a little bit beyond what to do with 100 localized FRBs. We do need to be thinking about, what Liam said. We should be running these massive simulations and false observations with 10, 20, 30,000 FRBs by 2030. Right. Are we going to learn to swim fast enough that we don't drown? And how do we prioritize this?
Yeah, and you used to be able to do a PhD with like 1 or 2 FRBs. Now I guess you're going to need like a couple hundred to get a PhD at this point. Yeah, and then lastly, so you could ask yourself, or you should always ask yourself, what are you actually trying to do? And I feel like, so this is not a condemnation, it's more a challenge to the audience. We often talk about understanding progenitors just in the pure mystery kind of point of view. It's an astrophysical mystery, what is producing FRBs, but I think we need to be a little bit sharper in what are we going to actually learn about compact objects and their relation to massive stars. What are we going to pull out that's going to be interesting to people who don't work on neutron stars? That's exercise to the student or professor, depending on what level you're at. And the other thing I wanted to flag is, didn't hear anyone mention searching a wider parameter space during the meeting. And the meeting was specifically about following up, but one way to follow up is to think about, well, given what we've discovered, what's the next step, right? The standing on the shoulders of giants kind of thing. And I think the upcoming experiments, some of them shown here, are really, really fantastic, and they're going to do fantastic things, but still get the impression that we're kind of like a bunch of kids chasing a football right now, because I think a lot of these experiments are probing similar frequencies, similar timescales, and they're going to do similar science. I think I would also challenge people to think a bit more creatively about still niche experiments that can open the parameter space, because I think we have every reason to believe that there are other types of FRBs out there as well. Do you have any final remarks, Keith?
There was just one other thing on that slide that I would mention that you touched on
But
earlier
not the
that we,
soccer slide.
not the
that-
soccer slide,
yeah.
but the uniform nearby sample idea that to really understand progenitors, I've heard several conversations of people saying that, you know, as Maria said, we need to be careful and understand our selection function and understand that we're actually getting a complete sample from locally, or at least, you know, large numbers in a well understood one. And it has to be nearby so that we can get follow up and, you know, resolve things in every band and learn what we're doing. And that takes a slightly different telescope from what people are building. Most of the telescopes on that list are not all sky. They're not looking at huge areas. They're looking very deep. So things like this burst project, which the timeline, I don't know, it's just a bunch of dipoles, which should pick out, you know, local events, things like that to, as Jason was saying, look in a different parameter space, because we don't have much in the way of local FRBs right now. We have, you know, the magnetar and the M81 one, both of which seem discrepant, very faint compared to everything else. So that should be a flag that we should be exploring that, I think.
All right. How would, so we have a little bit of time for a discussion session. How would you like to coordinate that?
Okay, well, maybe first let's thank Jason and Keith. Okay. So the rest of the time, maybe for like 20 minutes or so before the end of the day, it's just an open floor discussion. People raise their hands, you'll get the microphone, maybe to touch on points that wasn't mentioned in the meeting summary that you thought about in the minute or 2 minutes before. And the official title of this discussion session is what are the major and minor challenges for the field going forward, and where do strategies overlap? So yeah, open the floor for thoughts, comments. Anything about anything in this workshop at all?
Yeah, I guess I had a question about, there is a lot of emphasis on low DM events. And I know that from working with Chime, we tend to flag a lot of things that are low DM or just have a hard time because of our RFI. And I'm wondering if it's worth the effort to try to find a way to see how much we can extract out of this. Like if low DM events are so important, should we try to set some idea of what we want to do, or put effort towards trying to solve this problem if it's really seen as like a needed population that we're looking for?
So I'm just pessimistic that investment would, I mean, we should invest, you know, a reasonable amount there, but I'm just pessimistic the investment would pay off. It's low DM is just super hard, right? The RFI is awful. What we do have on Chime is Marcus's injection system, right? So we know what fraction of low DM things we're missing. So that system, you know, for building this volume limited nearby sample, right? I mean, we're not all sky, but we know exactly. I don't know, but it's in Caitlin's paper, right? But I mean, the thing is, we can inject just millions and millions of events with any parameters you want, and just know what we're missing, and that ability, you know, to create these, not, there'll never be a volume limited sample, you know, the Earth turns and stuff, right? But we will have could make a sample. We could put a lot of effort into making a sample, say in the DESI region, that is highly complete in redshift out to some redshift. It's high that we really do understand the selection effects as well as possible to try to get as something as close to a volume limited sample as humanly possible. So I really think that is if that's what we're after, then you're never going to get rid of the selection effects, but controlling them with that injection system. I mean, it's a gem, right? And we should use it and leverage it in every way we can.
Another comment I wanted to make with respect to like the low DM events, especially really bright ones that may be misflagged as RFI. If we could improve our VO events communication between observatories and between even like outriggers, if that's a possibility, then looking for coincident events could help us, you know, avoid that misclassification.
And I would just point out that, so the FRB mark that we found, whose DM was lower than the expected ISM contribution, that would have been thrown out by Chime because of that cut, right? And it wasn't just a fluke. NE 2001 and YMW both overpredict in that quadrant of the galaxy the contribution from the ISM. And you can show that by comparing with H alpha maps and H1 and stuff. And so you could be a little bit, you could engineer it such that you don't miss those, especially in the places where you know that NE 2001 is wrong.
Yeah, just want to add, I think we could optimize the RFI mitigation pipeline in Chime, but effectively you would increase the false positive, the number of false positives. But if, for example, we could use the beam information while doing real-time RFI mitigation, that could probably help in lowering the rate down. Yeah. So I guess like in short, I think there is room for improvement in detecting galactic FRBs.
And I think it's worth doing that, right? Because these nearby FRBs are the best candidates for like multi-wavelength follow-up, and once you localize them with the outriggers, you don't need as good a localization to actually get information about the local environment for really nearby sources. So I think it's worth putting the effort in to have a larger sample of those.
Yeah, we talked about this actually somewhat extensively in our Galaxy huddle over here, talking about the low DM FRBs and like when Chime FRB detected SGR 1935, how it was just a little bit of a fluke, and now we are calling back more kind of unknown galactic events. But also with Chime outriggers, we could start possibly exploring this even more. Amanda and I were discussing this. If you've now got events that are lighting up all beams at Chime and both the outriggers, then it's probably a pretty close, really bright event. And, we detect 60,000 RFI events at Chime per day. And of those 60,000, how many light up half our beams and then would light up half the beams at GBO and KKO? Probably a small enough sample to have ZARS be looking at those. And then we wanted to ask Liam how G-Rex was doing.
What's that? Oh yeah. So G-Rex is just kind of rebranded Stare 2, like antennas that point at the whole sky. But the idea this time is to send them all around the world to build up 4 pi steradians of continuous coverage. The first we'd like to be in Australia because then you get more exposure to the galactic plane. And we've built 2 of them. We have materials for 9, so that's 3 clusters. So hopefully it'll be on sky soon.
Maybe before we continue in the room, I'll invite anyone that's online maybe to raise their hand or unmute and speak up if you have thoughts on this. I'm just cautious that you're all very quiet on Zoom. Okay, there's no thoughts on Zoom.
Yeah, so I just wanted to comment on the, Chime is throwing out all our galactic events aspect. We have done some work to bring down our RFI false positives, and we are actually collecting galactic events now. They are not going into the main candidate stream of our extragalactic events, but they can be in the future once we, hook that up. And so there is prospect for those low DM events to not be thrown out because we think they're, below YMW and NE 2001.
So I have a quick question. I'm not a radio astronomer, so this may sound really silly, but what DM is too low? Like if you have some DM that you feel safe about, can you just do a volumetric annulus around and just say, this is our completeness? Does that make sense? Like DM up.
I was just going to say it's a function of latitude. So I would say there's no, and we don't, especially at low latitudes, we have no idea really what the ISM and Halo are contributing unless we have a really good localization and other information. I'll also say, but we can call back all DMs. It's just a question of if we think it's RFI or not, which I don't know if this is, I think we are getting rid of
I'm
30%.
That's what I meant about for the RFI, because I mean, if you did your complete survey, but it's a cone out of the plane, and that's your complete survey, great. You've got galaxy minimized, right? But I just wondered if it's RFI, is there like a DM that can say, oh, you're good?
We
above
see
this?
RFI from 0 to 10,000 DM units.
One thing I will just add to that is something that helps simplify the problem is that we're not just looking for low DM events in this kind of search. We're looking for low DM high flux / fluence events, right? We want things that are analogs to FRBs, but from the local universe. And that's not things that are, riding the, low SNR tail. So what we do want is we don't want to be blind to galactic FRB. I think that's the statement that we want to make. A galactic FRB.
Yeah, I'll just add that this GM issue is very telescope dependent, and different telescopes will have different selection functions here. And I personally think that the RFI issue about missing sort of the nearby FRBs is not the main issue. It's just that there's fewer of them to find, just because there's not that much volume.
Oh, I had a question for you, Liam. You mentioned this particular sight line where the models overpredict and you used H1 mapping to figure out that was the case. Can that be done like en masse for the Milky Way?
I don't know. I think we went into it assuming that the NE 2001 YMW models were the most robust and like H1 absorption was maybe the least or something. But if you look at that MARC paper, Vikram made this plot where he shows the sort of relative error as a function of galactic longitude, I guess. Not sure if you could actually map that out in 2 dimensions, but it's an interesting plot.
Yeah, so I had a question about, I guess, parameter space. And, there's been a lot of talk about trying to find longer duration things. And I just wonder, and with Krakow, we're going to try to do that as well. Thinking about the 3 second, whatever, 0.7 millisecond chime thing. And I was wondering, the one with like 7 pulses or whatever in it, right? I was wondering if people are trying to improve their detection systems to find more things like that, or designing systems that are going to be more sensitive to things like that, or if even longer things like the magnetars.
DSA was going to go for this also. Actually, the grad student Miles Sherman who's going to pick up this project soon.
Yeah, cool.
There's definitely there's team members here. I know Ziggy and Sriharsh and a few others were also thinking about this, and I think it's the sort of thing we absolutely have to do. And we've just been doing a lot of stuff, and it's kind of hard to do everything. But I mean, on the flip side is also the faster things like microsecond stuff, and that also there's lots of potential there, and that's truly frightening from a data perspective.
I was going to ask Vicky, I guess, follow up. What's the benefit of going for stuff that's faster? Like, is it just another question of finding faster things, or is there something more that we can gain specifically out of that?
Yeah, I mean, if there's a huge new population of things that are microsecond bursts, that what could those be? I mean, I guess we'd all just say neutron stars. Is that what we'd all say? Or at some point we'd start to scratch our heads. But I mean, the rate of sources that are really fast could be enormous. And we already see that these things are capable, but we have no sensitivity to them. So we better figure that out. Otherwise, we could be missing a massive population.
So first step there is, so in Aperitif, we cranked up the sampling time to 40 microseconds or 80 microseconds. And of the 5 bursts that we just published, they're among the 10 fastest, shortest FRBs ever found. So this gives you an idea that there's ways to explore there. I understand, and we talk about this for new surveys too, if you want to make a trade-off in beams, and then yeah, sometimes you lose, you give up on sampling rate because you want to make more beams and you only have so much compute. But I think there's a lot of interest there, especially if we for a certain number of emission theories. It's just it becomes interesting whether you can make something much shorter than a millisecond.
Yeah, I was going to say, I mean, it's other populations is a compelling case. The other compelling case is, don't forget, it's people just say millisecond, microsecond. It's a factor of 1,000. So for experiments where you're doing like time delays for lensing, or if you're doing photon mass, making your experiment 1,000 times better is a good investment, I think.
Or measuring scattering times.
Or measuring scattering times, or
I'll just say for Chord, so looking to sort of more future, the FRB search is being designed with a lot of knobs to tweak. So adjusting the temporal resolution, the spectral resolution, different spectral resolution across the band, binning scales, sub-band searches. There are a lot of things that are being explored in that. And we have plans to do sort of a baseline search and then also be able to modify it, mid-run.
Guys,
checking parameter space.
In terms of like front end systems, so like having baseline stability and stuff like that, is that something that people are thinking about trying to design into the system so that I guess like the pulsar people have not found these things in the past because they've had single dishes and all kinds of baseline crap that they've had to try to filter out, which has probably filtered out some of these like the magnetars type things that people have been finding that have long periods, right?
So on shorter timescales, we know the crab produces nanoshots. So, it's very clear that there are neutron stars that produce these types of ultra short pulses. And if you look on the plot that Kenzie published in her paper, you see largely unexplored parameter space at those short timescales. In fact, the M81 repeater and the crab are kind of the only two objects that produce these ultra short radio pulses. And, people are worried about the computational cost of doing these things, but, there are ways to mitigate this. There are semi-coherent techniques that you can use. They're published in, say, Baraksa K's paper. You can use them and you can probe those ultra short timescales. So, it's not inconceivable to me that it's just totally hopeless to even do a semi-coherent search per se. So I think we should be looking, basically.
I mean, are you referring to and follow up of repeaters at known DM? I mean, that's the thing that you can't afford to do, right? Is once you know the DM, you can always look for high scales. It's the thing that's really expensive is when you don't know the DM and going for short time scales, right?
Yeah, so I would say this, what I'm thinking is not when you know the DM, but actually doing a semi-blind search.
Okay.
Where you use the semi-coherent technique to basically do some amount of coherent dedispersion and then incoherently dedisperse just enough so you don't get DM smearing and scattering, compensate for that.
I see. Yeah. I mean, then in that case, just to plug the fact that once you know the DM, if you're following up repeaters, there is a lot of room to do way higher time resolution stuff at known DM.
Yeah, I agree.
That's something we should be doing. We haven't gotten around to yet.
Am I on? Oh, okay. Yeah, go to higher frequencies. The field of view is a big challenge, but dedispersion becomes easy at that point, and you get a lot of bandwidth. And people don't talk about it a lot, but it seems like FRBs become narrower at higher frequencies as well. At least the few cases we have seem to become intrinsically narrower, not just scattering. So it could be that they're pretty detectable on microsecond timescales at 5 gigahertz.
So just to change gears a little bit, one of the things that I've been thinking about as throughout this entire conference that is going to be a big challenge for our community is we're going to be talking a lot of different data languages now and a lot of different, dealing with the high diversity of the type of data that we're getting in and what we want to actually cross-correlate. And that's going to be an infrastructure challenge. And that's something that I think we need to start talking about together. And part BO events are a start of it. The dashboards, all the work that is being done by, Deeper, Wider, Faster and F4 is fantastic, but I think this is going to be a much larger challenge, especially, when we talk about 10,000 FRBs a year, that is more than a single localized FRB a day, right? That's the data rate we're starting to talk about. And so we need to think about how we are going to communicate data and how we're going to make all of these diverse, heterogeneous data products work together. And we're not the only ones running into this problem right now in astronomy as well. Is the other thing I want to throw out. So there are other communities that are starting to run into this exact same challenge, and it's worthwhile to think about how we want to do this as a community.
I'd also just add to that, I forget who I was talking at coffee with, but somebody pointed out to me that not everybody is using the transient name server to name their FRBs. And I just want to say that in the era where where you're going to have, this many, we better have a really, really good naming system. And, I think we converged on that. So I just encourage everybody to please make use of it.
Also on the topic of all of the FRBs we're going to have, I'd like to bring it back a little bit to the original motivation for organizing this workshop. We're going to have 10,000 of well-localized FRBs soon in a few years. We were a bit worried, like how are we ever going to get redshifts? In organizing the meeting, hearing about all Spherex and Euclid and DESI, LSST, my personal worry has been diminished a little bit. I'm a little bit more confident we can do this without having to write tons of observing proposals and compete for the same resources as other communities. How are people feeling about this in the room? Are people relieved? Do they feel like we're good? Things are going to work out well, or we are going to have a problem where we have all the FRBs, but we won't have the redshifts?
Well, I guess part of why I wanted to have the panel on archival data is just to try to understand what our prospects are for localizing host galaxies without having to look to new instruments, especially things that are soon to be coming online or looking like 2025 or something. If we're going to have these many new sources in the next year, what can we do with that? And I do feel like our prospects are good, but the missing piece that I think Mumty brought up is just having a consistent infrastructure for doing these localizations and coordinating among all these different data sets with different formats and things.
I guess the one thing I'd add to that, although maybe we can hear more again from the short GRB people, is it really depends what redshift range these are all going to be in. If these are all things that are going to be these pencil beams, and so you're getting hundreds of FRBs, but they're out at like redshifts of 0.5 to 1, then the archival stuff may or may not be so great. Whereas if you are talking about the population within like 0.3-ish or so, then you're going to be much better shape. So it really depends what redshift you're thinking of. And things in the south, like Rubin is going to be great for like the deeper photometric stuff, but it's going to be harder in the north for things at really high redshifts.
Yeah, I basically had a similar point, is that, you're starting to feel relaxed. Well, don't relax too much. Because I think if you're okay with FOTZs and maybe even coarse FOTZs, great. But if you need spectra, then it is hundreds. Maybe you can get 1,000 somehow. And if it's things that are farther out than say 0.3 or so, and depending, I think you said Spherex was 19 magnitude-ish spectra. Is that right? Yeah.
I went too quickly on the slide where I showed the sensitivity. So it's 19.5, but that's a spectral resolution natively of 40 or 100, depends on exactly what wavelength. You can always bend those up if you want to get deeper. You can get a couple magnitudes that way.
Yeah. So, you're limited to host galaxies to, 20 or 21 or something, and we've already seen that even close, that's tough sometimes. So it's going to be spotty.
Yeah, I think emphasizing what X had said earlier, like, my hunch is that 100 to 1,000's, doable in a few years. But when you're talking about 10,000 a year, that's a different game. And also, like what Anya said about was like 36 nights to study 50 GRB sources, right? Right. So that we're not going to be getting 30,000 nights of observing. I don't even know how long, but that's 10 years of observing. So it's going to be like using, multi-object spectrographs like Foremost or MSE if it's ever built to do this. Like we have to be thinking about getting into those projects and getting those up.
Okay, I see Mohit has his hand raised. So can you unmute and?
Sure. I think I completely agree with what people are discussing. So one thing, I don't think so compared to supernova community, we really need to get the redshifts of our host galaxies quickly, like within a week or so that we can do afterglow follow-up. So when we start detecting 10,000 galaxies, and if we are cordial enough to just share the data, one thing we can do is to have a multi-object spectroscopic observations, like wait for a month or two, have this catalog of galaxies and see if whether we can actually apply for a single observation rather than repeatedly applying for a few objects. So I think that's one of the ways by which we can optimize our use of optical telescopes. That's what I think.
That's I agree, and that's good, but they're only like arc-minute fields of view right now, and you have the new ones coming on that in the future will be like a degree or two, but how many you're going to get in that degree? If you have 10,000 already on the sky, okay, you can cluster them, but it's not going to be a really efficient use of those facilities, but it's better.
Like foremost, where you subscribe and get a few fibers, and there's like all these programs running at the same time. That would be the way to kind of get in.
Yeah, there you go. Yeah. So you
talked about the DESI. You could borrow a few fibers from DESI.
Means GWST can have like around 1,000 detections as well if you apply for the MOS field. But then if we have a justification of like, if we have 500 and 200 galaxies, I think the proposal would be easier to get approved in that case.
Bringing it back to Euclid, I was just looking up some of their numbers. They said they'll have 35 million spectroscopic redshifts. Pretty good. Over 15,000 square degrees. So then I divide the two. That's 2,000 redshifts per square degree. So now you're starting to ask yourself, is that a lot? There are probably 2,000 galaxies in a square minute. So no. So if you're optimistic that you're going to be paving FRB host galaxies with Euclid, forget about it. It's going to be super powerful for lots of studies, but be aware of what public surveys will be buying. Spectroscopic redshifts. And actually, they're not the greatest spectroscopic redshifts, but they are Griswomian. Okay. Anyways, just
yeah. So I
that's
think
the best we'll be doing with public surveys.
Exactly. And I think though, I'll just reiterate what was just said. I think the way to go though is to make friends with all of these big like DESI and Foremost and other things, because yeah, you're probably not going to have the spatial density to justify like an entire pointing of these multi-object things just for FRB hosts, but they always have spare fibers. So these surveys are going to be running. So just, yeah, have MOUs with all these people you made already, but just start putting in your galaxies.
Yeah, I just want to add a comment there. There is also a multi-fiber spectrograph, which is going to be on the Subal telescope on Mount Care, which is the prime focus spectrograph. And then it's on the 8-meter telescope. And then the field of view is 1.5 square degrees. So I think, and then they're always looking for fillers. So that might be an option there too.
So I'll just add something that I was going to say earlier is that, yes, that's great to get those fillers, but that's like 5, 10, 2, 8, whatever. You're still not going to get 10,000. I mean, you could try, but it's going to take a long time.
Just to note that it is a couple minutes past 5. And I want to give Ziggy the floor for the closing remarks, but at least, at least the people in person can continue this discussion after. But yeah, I'd like to thank everyone for the great discussion.
I shouldn't have brought up that last point because now I'm worried again. Well, that was a great meeting. It was really nice to have all of you here, to have all the contributions online. There's some action items I think that came out of the discussions. I don't have them all ready out the top of my head. I've been hearing talks about coordinating VO events between observatories, talking about windows. There were some takeaways in the meeting summary from Jason and Keith that it's also on the amongst the slides. I made recordings of all the sessions that I'll be uploading. So people can look at all of the discussions, all of the talks at their leisure, revisit all of those insights that people brought to us. I hope we've been able to make some new connections. It was really nice to have all the people from the big surveys here that don't usually join the FRB telescope. So thanks Michael and Gautam online and Dustin to join us for that. We can do more of these sessions. We now know at least one person from each collaboration to talk to. And so I think we should really be doing that. Other than that, I'd just like to take a moment to thank the SOC. So Adam is there, Justus Kenzie, Paul is here, and Jane. I don't know if Jane is still online. They've been putting the program together for you, and I've been talking to all the speakers and inviting them. And then the LOC, so you've seen Amanda and Ayush run around their microphones, and they've done a lot of the other things, amongst which organizing the dinner last night. And then there's also Kara, who you haven't seen much. She did a lot of the work in the background for organizing, getting this together. And then there was Marley, who did a lot of the AV at University College in the conference center. So let's thank all of them for running the meeting. You're very welcome. So thanks everyone for coming. Safe travels home. Please keep discussing here and online, and hope to see you all again soon.